Hello, and welcome to today's webinar on smart foundation solutions. We've had a lot of interest in foundations and foundation design, so we thought it would make sense to host a session and go into a bit of greater detail. As a bit of housekeeping before we begin today's webinar, we strongly encourage your questions and participation. So please drop your questions into the Q&A button located at the bottom of your screen. You can test now if it's working. You can just drop a note or say hi, anything you like. So we can see that we are getting your questions in the Q&A area. Okay, I see some people testing it out. Great. Thank you. Okay, so just a reminder that today's webinar will be recorded. And now I want to introduce you to today's speakers. So it's my pleasure to welcome Adrian Maroli, Director of Sales at Polar Racking. Adrian has over 20 years of experience in solar and B2B markets. He leads our US and international sales team, building strong partnerships with developers and EPCs, and he drives Polar Racking's growth across utility and commercial projects worldwide. Next, we have Arash Yazdani, Chief Operating Officer for PRI Engineering. Arash is the driving force behind PRI. He is also a designated professional engineer, and he has been working in the field of geotechnical engineering for over 16 years, specializing in solar foundation design. Arash and his team at PRI have been involved in geotechnical investigations and foundation design of hundreds of solar farms across Canada, the US, and the Caribbean, in addition to geotechnical investigations for municipal infrastructure, airports, and roadways. Now I'll turn it over to you, Adrian.
Thank you, Marlene, for that great intro. And thanks to everybody who's taken the time to join us today. We've got a bit less than an hour's worth of topics to cover and content, and we've saved a good 15 minutes for questions and answers at the end of the session. So as Marlene said, feel free to pop in your questions. Ideally, we'd like to address them all at the end to not break the flow of the presentation. But if anything is pressing, just please make sure to put it in the comment section, and one of our moderators will read it out. So again, just to highlight the agenda today, we wanted to talk about foundation design and why they matter more than just the stamps. We want to look at what the best practices for the foundation selections are. And there's a lot of emerging trends right now in foundation technology and design. People are kind of swaying away from your traditional foundation. So we wanted to take time to look at that. We are definitely going to focus in on manufacturing benefits of the round HS. So that's the hollow structure sectional. And we'll look at one case study, which is Hurricane Fiona, closer to the end, just to kind of talk about why the quality of the racking and obviously the foundation design is important, and what are some of the damages load. And finally, we'll wrap up and talk about the tips of reducing foundation costs, and especially what's a very hot topic right now is lead times with steel manufacturers kind of being put through the mill, no pun intended, and lead times stretching out. Hopefully that'll help for all the people on the call trying to build projects and get delivered to site before the end of the year. Hopefully we have some solutions for you given the time strain that we have at the moment. So next slide, please. A little bit about Polar Racking. For those of you who don't know us, Polar Racking has been around for over 16 years. We've got over 4 gigawatts of installed experience. Really what we strive to deliver is our highest value in terms of steel and engineering at the lowest cost per kilowatt. So we really focus on value internally here. We support global clients. We dominate in Canada and the Caribbean and have a very good presence in the US. As you can see at the bottom of the screen, we're also compliant with US domestic content for those of you who are after any of the tax credits or adders. And today in our portfolio, we essentially do a fixed tilt system. We have a tracker, We do a lot of carports, and we have our own designs for agrivoltaic solutions with a few patent pending. And we also manufacture all of our foundations. So we're not just a racking supplier. We do focus on everything above grade and also below grade. In terms of our nomenclature for our products, next slide, please. We have our fixed tilt system, which is known as Core or Core Flex. So that's essentially all of our ground mount, whether they are DG or utility scale, single post, dual posts, and all foundations in between. Solex is the name of our patented tracker. For those who haven't worked with us, we do not have a torque tube, so it's a very different design and conceptually different approach to using a tracker in the field. Shield is our carport portfolio, and our agrivoltaic, like I said, is in development, and we currently have a few projects across North America in the growing field of agrivoltaics. And from a foundation perspective, we pretty much do everything under the sun. Again, no pun intended. From driven piles to ground screws and helical piles. And we carry all three forms of ballasted options. So whether that's a precast concrete ballast to a pour in place and a geoballast or gabion basket ballast as well. So next slide. I'll pass over to Arash to talk a little bit about PRI.
Thank you for that, Adrian and Polar team. Appreciate you having me here today. So PRI Engineering, we are a full-service geotechnical structural engineering firm that are servicing Canada, US, and the Caribbean. We've worked on projects as far north as the Arctic Circle and as far down to the Caribbean. Over 100 plus years experience with 6 licensed engineers on staff. We have completed over 500 projects, with the majority of them being solar projects. And we have our own in-house soils, concrete, asphalt, and aggregate laboratory. Next slide, please, Marlene. In terms of geotechnical engineering services for solar foundation design work, we do preliminary feasibility site review, geotechnical site investigations, site-specific frost susceptibility analysis, corrosion analysis of subsurface conditions, pre-production testing, and everything we're doing is looking for the most cost-effective solution while meeting the engineering requirements of the region and the project. We can also, during construction, assist you with quality assurance, quality control, by developing a installation database that will help you track conformances to verify that foundations are being installed as per the design. And as part of our soils laboratory, we also do thermal resistivity testing and also do in situ electrical resistivity testing during the geotechnical site investigation. So we can really step in at any point. We can start, as early as the preliminary feasibility site and take you right to the end of the project. Or if you've got a project that you've been working on for a couple of years or a couple of months now, and you want to give PRI a shot to look at your project, we can build on the work of other consultants as well. Next slide, Marlene. Last week we added to our team Ecora, who is a 6-office firm in British Columbia. So by doing so, we've been able to add biology, civil engineering, GIS services, asset inventory, and a larger civil, structural, and geotechnical team to our existing team. So now PRI has grown to over 130 people. Back to you, Marlene.
Thanks for that, Arash, and congratulations on the acquisition. And thank you for joining us. It sounds like you're under the weather too, so I'm glad that you didn't cancel. So moving on, we just want to make sure that we spoke about why foundations are important. We all know all of the liability really lies subsurface with the foundations, and a lot of times, we don't do enough homework on the front end when developing projects to look at, what the soils are like, and we just do preliminary geotech work. So what are our foundation options today? I mean, amongst others, we've got the helical pile, we've got the micro piles at the grouted post, we've got all types of driven posts, whether they're I-beams or round posts. We've got ballast, like we spoke about, and ground screws. So again, depending on where your project is and what the initial geotech is coming out, we would want to make sure that we focus on ensuring we have the right foundation type for the right soil. So next slide, please, Marlene. So why does all of this matter? Why does foundation design matter? Obviously, there's the structural stability and safety, and I think our case study at the end will really speak to why that's important, and not to just go with what we're used to doing per se. There's a site-specific soil and climate adaptation that we need to consider. A lot of times within the same project, there's different soils, and which requires different foundations within the same project, within the same boundary. Definitely the cost efficiency, because we know that working with concrete, for example, can really blow out a project and might not make it pencil. So making sure that we're always cognitive of the dollar per watt as we're developing the foundation. The longevity and durability come back to both the long-term effectiveness of that foundation design, but also from a finance perspective, we have to look at what's the warranty and what's the design life cycle on the foundation design that we're creating to satisfy finance a lot of times and to get to NTP or LNTP. And then finally, we want to look at the energy performance as well. Next slide. So I'll pass over to Arash to kind of go into the details of the foundation design and what the steps are to get to construction.
Okay, thank you for that, Adrian. So at PRI, we do have a phrase that we like to kind of live by. It's let the ground do the talking. A lot of times working with other installers, racking suppliers, or developers, we've seen individuals or organizations favor a certain foundation design regardless of the geotechnical considerations. So with that being said, we kind of dubbed the phrase "let the ground do the talking." In other words, you need to know what the ground conditions are before you select your foundation. You're after some key geotechnical parameters, and always considering constructability when you're developing these designs. Some of these parameters, one of the largest risk items as it relates to foundations at this magnitude is obstructions. So that could be either shallow bedrock or cobbles and boulders. So having a good quantification of those parameters is very, very important. For this reason, we do recommend, if you are adamant to do boreholes, that you're also doing test pits, because it gives you a very good visual representation of these obstructions in the subsurface. In terms of constructability, depending on the size of your project, we kind of use the 1 megawatt mark as kind of the minimum. Not to say you can't be doing studies below that, but anytime you get over 1 megawatt, it definitely makes sense to do pre-production testing, pre-production work to establish the constructability of the proposed foundation prior to making your order. This is to ensure that the foundation you're ordering hundreds and hundreds of can be repeatedly installed with a proven and methodology that can easily be controlled from a quality standpoint, over the site. In a lot of cases, what we see is that not enough geotechnical information is being collected at the investigation design phase, which leads to a large portion of the site being unknown, having unknown subsurface conditions, and that can, negatively impact the constructability, which can lead to very, very large change orders, which, at times is great for the constructor, but not always in favor of the project and the developer that's going to be fitting the bill. Next slide, Marlene. So some best practices for construction inspection. This is often something that is not fully appreciated on solar projects. A lot of people feel that they get a stamped IFC drawing and that's the end of the work for the geotechnical engineer or the structural engineer. Quality assurance of pile erection is very, very critical to have a successful project. This can be done in conjunction with your contractor. We actually prefer it. Um, it helps kind of keep the cost down and also kind of creates a collaborative environment that doesn't create um, friction between the engineer and the contractor. The main goal of this would be to verify that the design assumptions have been made. We are making sure that key design components are met. And establishing a list of non-conforming piles, which then can be tested during testing, during the production work. Then we can also provide deviations from the requirements that were established at the IFC stage. A lot of people ask, why are you able to refine if you've gone and done pre-production to start with? Um, it is kind of a statistical process. If you have a larger data set, you have higher statistical probability that you're not going to have failures. And for this reason, we highly encourage this. The other thing to keep in mind is that sometimes we're developing a design for an entire site because you might have some anomalies in your design during the pre-production phase, in which case uh, you might be having, lower or higher production requirements because of certain anomalies. When you have more data, more concentrated installation data in a smaller area, you're able to refine recommendations for some of those more confined areas that may have varying conditions. The ultimate goal of this uh, construction inspection work is to develop a general conformance letter. This basically helps kind of with the insurance of the racking system. It's your foundation engineer of record signing off and saying that everything was installed as per the design requirements, which should alleviate any racking warranty claims made down the road from pointing them back at the foundation. Next slide, please, Marlene. So, one of the specific topics we wanted to talk about today was the benefits of the round HSS versus a W section. So, a round HSS typically, in our experience, offers about 30% higher skin friction compared to a W section when used for a driven foundation, which obviously results in a slightly reduced embedment length, which will result in lower installation costs and lower supply costs. Next slide, please, Marlene. The the one kind of benefit of this system is that with a round HSS versus a W section is that a W section requires you to have a bolted connection where you can see here this is a friction connection and your degrees of freedom in the vertical axis is virtually unlimited. Whereas if you're using a bolted pattern, you need to be at a very precise location. A lot of people opt to use a pre-punched W section, meaning that you need to get at a very, very precise location for the embedment depth, or you're needing to do field drilling in the field to ensure alignment of the W section with the connection to the racking system. Next slide. Just in terms of the tolerances with the Solex system, your foundation does have the tendency to move in the east or the north-south direction as well as the east-west direction. So these tolerances that they've kind of built into their purlins help accommodate that. These are real life these are real the realities of installation, that you do have foundations that move. We did talk about obstructions. You can install through some of these obstructions, but in a lot of cases, you you need to have a racking system that can accommodate it. And I can tell you, having worked with a number of racking systems around the world, that not all systems are as forgiving as this system here. Next slide, please. So going back to the W section and round HSS, one thing that's very advantageous about a round HSS is that there's no weak axis bending. Your bending capacity in all directions is equal, whereas it varies quite a bit depending on the final position of the W section. So, I mean, racking systems, W sections, in most cases, they are designed to accommodate like the strong axis of the foundation, but in some other cases, such as earthquake loading, seismic loading, if you've got a single axis tracker that has a very, very large, heavy motor or other large auxiliary components, such as combiner boxes or string inverters attached to the foundation, you could have some negative impacts from seismic loading standpoint that does impact the weak axis bending, which will require you to upsize that foundation substantially for those cases. So that might in some cases only impact the motor pile, but that's not an impact that you would see with a round HSS. Next slide, please. The other benefit, if you have transversional rotation, a circle is a circle. It doesn't matter like how many times it spins around, but a W section, there is a limit where it will not, from a loading standpoint, be able to resist the loads properly. Furthermore, from a racking adaptability standpoint, if it does come off, if it does skew off of plumb or the required kind of angle, there is a possibility that you will have to remove that, reinstall it with the racking system, because it just can't physically accommodate it. Next slide, please. So just to go over some like key advantages, welding and automation ready. So around HSS is a lot easier to put together. It can be welded with robotic. It's a single seam, so it's a very, very simple process compared to welding of a W section. Because a lot of these materials are often extruded, they can have very uniform wall thickness and have maintain the geometry of the shape throughout the whole member. You have enhanced corrosion protection, so the center of the interior portion of the foundation is um, less susceptible to corrosion because it's not always in contact with soil. You do have the development of a soil plug, which is one of the benefits of why we end up with 30% higher skin friction, but that does not typically equate across the whole foundation. And corrosion is more of a concern kind of at grade where your soil plug does not move to. The round geometry simplifies rotation, alignment, and CNC-based fabrication, which just means that there's more automation, more robotics work, which will result in cheaper manufacturing costs. We talked about it a couple times already. When we're utilizing these sections for a driven foundation, there is, approximately 30% higher skin friction, which will result in approximately 30% reduction in embedment depth. Next slide, please, Marlene. And of course, a lot of pipe is used for a lot of other applications. I'm not saying that W sections aren't, but one of the kind of benefits of around HSS is that it's used in oil and gas uh, for pipelines. So, obviously something that's used all across North America and very readily available. And that does make a lot of um, readily available material easily procured. And then, of course, all of this helps us get to the reduced delivery time of 3 to 5 weeks, which, will benefit a lot of your projects at great length. Next slide. Okay, I'll turn it over to Adrian to talk about a case study.
Yeah, thank you, Arash. Hopefully that was helpful for everybody to understand what some of the main differences were. I tried to answer a couple of questions in the chat, but we definitely will address all of them at the end. We've got maybe 5 or 10 more minutes of content before we open up the floor. So again, we thought it'd be really important to talk about real life scenarios, and the case study in particular we pulled up was Hurricane Fiona, which hit the eastern seaboard of Canada and the U.S., northeastern U.S. In 2022 in September, with over 100 mile per hour winds. We are extremely well established with our number of projects that we've built in Eastern Canada. And so it was interesting to see some of the aftermath, given again the value and the foundation design that we opted to go with, along with the quality of our racking. Next slide, please. And so again, if you're not designing for the proper wind loads and snow loads, this is a really good example of what can happen, what can go wrong. Obviously, we don't wish this on anybody. But the reality is when we are doing design life cycles of 35 years plus, but we're looking at coercivity, but we're not looking at wind and snow loads properly. Unfortunately, there's a lot of investments that could get wiped out. And this doesn't look good just for the manufacturer at hand, but also overall for the industry. It's not something that we want to show or see. So it's super important. Like on the left, you see Nova Scotia, a smaller residential project, and then in a larger utility scale project in PEI, where not only was the steel all bent out of shape, but a lot of the modules were lost, et cetera, et cetera. I think a picture's worth 1,000 words. But if we go to the next slide, we can take a look at like where all of the projects at that time we had in that area, and all of this area in Eastern Canada were affected by these winds. Like I said, over 100 mile per hour winds. Customers, over 500,000 customers lost power, and 95% of the population in these provinces were out power for days, if not week. And if we look at one of these projects, we got an email from a customer. Next slide, please. Just kind of highlighting how important it was that there's a lot of options in solar and renewables, and they chose to work with us and have been working with us in the past, and just solidified the relationship, and is also a testament to why 80% of our ongoing revenue is through existing customers. It's mainly because of the quality we deliver, and more importantly, the engineering that we do up front, and ensure that we're always preparing for the worst case scenarios. So again, this is Dr. Pletner here, just attesting and very casually standing by her project. Next. Sorry, my lights went off. I'm in a conference room. So hopefully you guys can still see a little bit of me. But just in summary here, we just want to talk about, again, the HSS. I know that there was a question in the comment section. So yeah, HSS is the hollow structural section. And again, we're looking at making deadlines for the end of the year. A lot of people are trying to safe harbor and get piles in the ground. So again, we're trying to be as creative as possible, given the scenario that we have in the U.S., a bit less in the in Canada. But it's definitely an efficient design. Arash kind of spent a lot of time talking about the uniform strength. It's symmetrical geometry also means that it's much easier to produce and is also used in different fields, so they're readily available, and it's easier to shorten lead times. For those who aren't following the market, I mean, lead times for steel have been pushing out for the past couple of weeks more than ever. We just announced a tariff on Monday of 100% in China, so that's also going to affect not only the cost of domestic content, but domestic steel, but also the lead times will get pushed out because a lot of our projects that require the steel will take the backseat to other industries who require even more steel, and unfortunately, the mills prioritize based on quantity. So whoever's buying the most tons of steel gets pushed up the totem pole. In ground mount solar or carports, the amount of steel is nothing compared to pipeline and construction. So standard construction, and then finally it's reliable and readily available, which is what I was alluding to. Every industry kind of uses these round posts, and so to use these round-driven piles makes a lot of sense for wherever the foundation design allows for it. Next slide, please. So some of the key takeaways, again, we're kind of like hammering this home, again, no pun intended, but the smarter the foundation design, the greater project reliability. We've said it, all of the subsurface risk is the bulk of the risk of the project. Everything above grade we can predict, again, with loads and workmanship of the install. But building in an area where we're not sure what's happening below grade is our biggest risk. So take the time to do the geotech, take the time to do the pre-production testing, pull testing, to ensure we have the best design for our foundation before it gets stamped, and avoid any kind of disasters in the future. Next slide, please. Selecting the raft foundation again for each site. We can go with driven piles or grouted piles, micro piles, helical, ground screws. Sometimes we have a lot of projects where we have multiple foundations within the same site, just due to the nature of the subsurface conditions. So again, hence the bigger your site, the more we encourage you to do pre-production testing to remove that subsurface risk, which is probably our biggest risk in developing ground mount systems. And lastly, if we go to the next slide, we want to make sure that we can still pencil these deals. We want to make sure that financially it makes sense, and with costs going up, the best way that we can reduce that is by looking at alternative designs where we can get a better dollar per watt, and the HSS, or the driven round post, is a great alternative to that. Not to mention the lead times for people who are trying to build before December. We can still get foundations delivered to site before the end of the year. And again, we spoke about some of the real world projects where such designs helped us keep our projects when faced with high wind loads. And last slide, or one of the last slides. Oh, that's it, last slide. So again, thank you guys for taking the time. We have 25 minutes left for Q&A. I'll let Marlene moderate that. And thank you, Arash, for your time and all your insight. It's always greatly appreciated. Hope you feel better. And we'll now move on to replying to the questions that are in the chat. And if there are any more questions, feel free to put them in the chat. I'm not sure, Marlene, if they can unmute and ask, but we'll also have our VP of Operations join us, Samal Radi, for the Q&A session. Thank you again.